Hello and good day. My name is David Frey and this is my Lab 4 report. So going straight off into it, the purpose of this lab is to use a simulator, the CCK simulator specifically, to help us get a more profound understanding of circuitry. We hope to predict the behavior of circuits containing resistors in series and in parallel, use the simulator to examine the behavior of ohmic resistors and capacitors, and some important fundamentals that you should know before going into this lab would be concepts such as the energy conservation loop rule and knowing that V voltage is equal to the current times the resistance. So at the start, the change in charge conservation in series circuits, we were asked to set up a series circuit that contained two 1.5 volts batteries and had ammeters measuring the voltage across. We were asked to predict what the current would be given resistance for our circuitry, and we found that it would be 0.02 amps. Well, once put into the simulator, we found that this was the value that our circuitry was giving us. And if you reverse the connections, which was a question that was asked, we found that the current magnitude does not change, but the current was going in the opposite direction. So later on, we were asked to disconnect the wires from each other and replace them with a voltmeter. We put the voltmeter to measure the voltage difference across this severance, and we got 3 volts total. I'm not sure if I did this part right because I think the current was supposed to say 0.02 amps still, but in this case it just says 0 because there's nothing connected to the circuitry. So moving forward, we were asked to chart the voltage drop across the series circuit. Well, we have a gain of 3 volts going from points A to B, and nothing changed going through the wire, but then at point C to D is our first voltage drop being 0.96, and then we have one further down from points E to F being 2.04. which, as you can see, is corresponding to the locations of our resistors. So questions part 1, because this section did come with, its own separate ones. Adding a voltmeter to the circuit, we found did not alter the current readings of the ammeter, as the voltmeter does not provide any resistance to the circuit. In addition to the next part, we still found no change in our ammeter reading. And for the final part, it was asking if you place the ammeter in parallel with the ohm resistor, what happens? Well, we found that it was reading 0.06 amps after placing it in parallel. Next, we were asked to calculate resistance using V equals IR for the 47, 100 ohm resistors and then the wire and the ammeter. Well, being this a simulator, our wires and ammeters are ideal, meaning that they shouldn't have any resistance, so they were both 0. And we used our current value and our voltage to find that the resistance was 47.95, which is pretty close, and then 102.05 ohms. So continuing, we were asked then to build an RC circuit where we found that the light was going out after a while once the battery and capacitors were attached, kind of showing the time it was taking for the capacitor to charge and discharge. Current was found to decrease over time, and then we measured and recorded the amount of time it took for the capacitor to charge given the resistors. So we had a 10 ohm and a 20 ohm resistor. So the 10 ohm took about 6.79 seconds to charge, whereas the 20 ohm was 12.83, and then vice versa to discharge. It took 7.23 seconds for the 10 ohm and then 18.66 seconds. We then went on ahead to use our voltage values to plot and find our RC. We found that we had a slope of negative 0.13 with an R squared value of 0.99, showing that we had a good fit. And we measured, using our RC, found that for the entire voltage to drop, it would be 7.24 seconds. Next. So finally, if you were doing this lab in real life and used an actual ammeter instead of an ideal one, what would happen? Well, the real ammeter would provide minor resistance, which would alter our current value. And if we were using a real battery to charge a real capacitor with no resistance in the circuit, what would happen? Well, the simulator says it would charge instantly, but in this case, it would just charge very fast because you have to account for minor resistances in the wires and the batteries and how long the battery was fabricated.